You're listening to Angelneers, the podcast. Angelneers is a Silicon Valley community for startup builders, where founders and operators share their firsthand knowledge on how to build and scale startups. I'm your host, Oleg Kuchikov, and our guest today is Sadegh Riazi, co-founder and CEO of CipherMode Labs, the next-generation computation platform that preserves the confidentiality of data during all states, even during the computation itself. I'm excited to bring on Sadegh to talk about the changing status quo of using advanced cryptographic technologies and democratizing secure computation. But before we get into all of that, Sadegh, welcome to the show.
Thank you so much for having me.
Yeah, excited to learn more about you. So let's start there. Tell us a little bit about your background and how you got started in or interested in encryption.
Sure, happy to. So at CipherMode, what we are building is a new platform, a new way of using and managing data. And the key insight here is that it's actually possible to keep data confidential even when you're using it, which sounds a bit mysterious and even contradictory, but it's actually possible. So it turns out that machines can process encrypted data, and encrypted data refers to data that is locked, is unintelligible, but humans can't. So anytime you send any data securely over the internet, for example, your credit card information, your personal information for any web-based services, your data gets encrypted on your machine so that when it travels through the internet, nobody can actually see it, understand it, or intercept it. So that's the whole idea behind encryption. And it has been around for a very long time. But what comes with traditional cryptography is that whenever you want to use it, whenever you want to see data, you actually have to decrypt it, usually using the same secret key that you use to encrypt it.
So that's actually one of my questions. Like, how old is this? How long has encryption been around?
Well, the idea of encryption goes a long time ago, like even to ancient era. Like it's a very important capability to obfuscate information. Like it used to be the way they used to do it was they used to change letters. They used to do some like rotations of the kind of like a sequence of letters you use. But those things are very easy to break, and that's why we are not using those approaches anymore.
Right. Like I'm familiar with kind of, I guess, the archaic versions or I think of encryption, I think of like a cipher or something like that, Da Vinci Code type of thing. How long has like computational encryption been around? Because that's what you studied, right?
Yes. Yeah. I mean, so what is new about what we are doing is that we keep data encrypted even when we process it. So what we can do is, one example is when you want to process medical images, you can encrypt that medical image on the hospital side and send it to any AI company for them to process it. And they won't be able to look at the data, but they will be able to process it, which is very interesting and cool. The core idea came out about 4 decades ago. The first protocols, the first solutions to be able to do something like this, which was a pretty big deal in computer science. And later on, it got improved and improved, and the speed got much better to the point that now we can do pretty cool stuff. It's not sci-fi anymore.
So 40 years ago, I mean, it's like predating or right around the beginning of the internet. So it's been around for a long time.
Exactly. That's exactly why I was shocked when I started my PhD. When I started my PhD, I was introduced to this field in cryptography, and I couldn't believe it that this technology has been around for decades, and we are still not using it in any meaningful way or at large scale. And there are a couple of good reasons for it. One is that it's extremely complex to build systems that can process encrypted data. It's hard to use those systems because you need to have some domain expertise and knowledge in cryptography. And the other thing is that it takes much longer to process data that is encrypted compared to regular computation. So if you want to process an image, and if it takes like 1 second, previously you had to spend like hours, if not days, to process encrypted version of that image. And that's why, because of that complexity and computational overhead, there was like a very, very limited deployment of the technology overall.
Can you tell us more about, before you did this in business, you did, it looks like you were more of a researcher. You did PhD, you even worked at Microsoft on a team called SEAL. Can you talk about that experience and what you were doing prior to starting a business?
Sure. I got introduced to this field 8 years ago, almost exactly. And I really tried to understand what are the main problems that we can't use this technology today. And really try to understand that. And there are a couple of different ways of thinking about this field. One is at the application layer, one is at the protocol level, algorithm level, and hardware level. And it was pretty rare at the time for someone to work on all these layers to have a good grasp on what's going on and how to improve the system end to end. So I tried to do that. I tried to get my hands on a couple of different projects that address these layers to have this like holistic view on what's going on. So I spent 6 years on my master's and PhD at UC San Diego. And after that, I started working at Microsoft Research in a team which is called Microsoft SEAL team. And this is a group that is well known for homomorphic encryption, which is one of the ways of processing encrypted data. And I spent there for some time. I did a project which was creating a new CPU, a new computing chip to process encrypted data much faster. And the idea was that we wanted to provide this as a platform for other people to use the system, run their computation faster, and essentially accelerate the adoption of homomorphic encryption in particular and secure computation in general. The project was actually very successful. For the first time ever, we reported 200x performance improvements compared to a standard Intel CPUs for the same task. And that's led to pretty, I would say, big influence in the community, as well as, for example, US Department of Research, Defense Research Agency. And it kind of like opened a new way of improving systems for secure computation. There are many ways to improve secure computation. One is you can think of better algorithms and better protocols that are more efficient. The other way is that you can think of like better hardware that is custom designed for secure computation. Similar to how we are building custom chips for AI. On iPhones, on MacBooks, you have chips that are specifically designed for neural networks. And we didn't have these chips a few years back. And because of those chips, now we can process the same algorithm, the same task much faster. So I was trying to have take the same idea and apply it to secure computation. And after that project, that's when me and my co-founders, we started CipherMode, and yeah, that's where we are today.
I want to understand like what's out there technology-wise. You mentioned secure computation, and we've talked about homomorphic encryption. How many ways are there to securely compute data that exist?
Yeah, it's a very good question. If you want to have formal security guarantees that you can actually prove that nothing would be leaked, there are only two ways to do it. One is homomorphic encryption, and the other one is secure multi-party computation. There are not more ways to do it. And they use different tools within cryptography, but essentially, and they have different trade-offs, but these are the two major paradigms.
Okay. And can you talk about how those are like similar and different?
They are similar in the sense that they both process encrypted data. There is a notion of like secret key, and they are both based on provable security. They both provide provable security guarantees. They are different because the way that you do these computations are kind of like it varies from homomorphic encryption to secure multi-party computation. In homomorphic encryption, you're using something called lattice-based cryptography. And there, you literally have a secret key, you encrypt data, you send the encrypted data to other parties, they process it, they can send it back to you, and you're the only one that can open it. So that's one way of thinking about it. The other way of thinking about this goal is that you can break real data into different pieces that none of which can leak any information. Let's say I have some personal data, I can break it down into like 3 pieces. I share it with 3 servers. Each of these servers only sees like a randomly looking data. It looks like garbage to them. But the insight here is that you can start manipulating these pieces until you get the outcome of your computation without leaking any information to other parties. So it's basically, we like it more, and that's why we're working on it, because it's more flexible, it's more efficient, and it can add more data owners. It's not about like one data owner or 2, it's about any number of data owners.
Interesting. Along the lines of like who's owning this data, you mentioned DARPA and maybe even healthcare earlier. I want to know just generally like who's using this kind of technology? What are some of the potential use cases for this secure encryption?
In principle, there are many, many use cases. Today, you're right, it's mostly used by governments to process sensitive data. It's used by healthcare institutions to do collaboration without violating patients' privacy. It's used by some big financial institutions and banks. For example, one very neat use case of this technology is that you can find far more fraudulent activities and money laundering activities by sharing data securely across multiple financial institutions. That way, you can find far more complex fraudulent activities than just like if you have one single view by one bank. So it's much different.
Okay. Next, there's this like widespread industry belief that there has to be this natural trade-off between secure data and usable data. Can you talk about like why that exists, and is that set in stone, so to speak?
Yeah, it's not set in stone. So that's the punchline. Basically, the reason that people think that is in the absence of this technology, there's really no other way to use data. You have to have access to the data. If 2 companies want to collaborate and do something better, one of them or both of them have to share their data. They need to send a copy of their data to the other organization. There's just no other way to do it. With this technology, now you can come up with far more interesting ideas and very influential ideas. Like you can have the notion of like data marketplaces, where individuals or companies can rent out their data without losing data ownership, which is just like a brand new concept. Like if you have some health data on your Apple Watch and you want to rent it out in exchange for dollars or in exchange for just like doing social good, but you care a lot about your privacy, currently there is really no good solution for that. But if you have secure computation in place, you can rent it out for specific medical studies or for a specific goal for predetermined period of time, and your data can only be used for that period and for that computation. So we think that no longer we need to choose between data security and data utility. Thanks to this brilliant technology, you can actually have both at the same time. It's a little bit more costly, but we think eventually, if not all, most of the computation would take place over encrypted data.
So you decided to start this company, CipherMode, and the technology you're using is secure multi-party computation, not the homomorphic encryption that you studied. Why is that?
So with my experience working on homomorphic encryption, I saw that there are some obstacles in getting to the system that is like very scalable, very efficient, and very general. And I thought that the secure multi-party computation, which was the focus of my PhD, is more suitable for that goal. It's easier to build scalable systems. It's more usable. It's easier for non-cryptographers to use it, and it's faster. So overall, we think that the trade-off was in favor of secure multi-party computation.
There exists like this skepticism around the potential use of it in the community. Can you discuss that and maybe speak to that?
Yeah, sure. So even in the beginning of my PhD, about 8 years ago, there was a lot more skepticism around using secure multi-party computation, as you mentioned. And there were good reasons. Like some of actually colleagues or security people, they call it like toy technology. It's not going to be used at all. And the main reason was computational overhead. It takes a long time to process encrypted data. I can give you some real numbers. 8 years ago, if you wanted to do a simple image analysis and classification task that takes like 1 millisecond on any standard CPU, if you want to process the same thing but the encrypted version of it, it used to take 300 seconds. So that huge gap, really, 300 seconds. So we are talking about like orders and orders of magnitude difference. But then gradually, through the contribution of like many people, many brilliant folks, the overhead was brought down to the point that, yes, it's not 1 millisecond, but it's 10 milliseconds. Now we can talk about it. Now, maybe it's worth doing it in exchange for 9 more milliseconds, but now we can process real encrypted data. And if we can process encrypted data, now hospitals can collaborate. Now financial institutions can collaborate. So we think that the value that it unlocks is far bigger than the additional cost.
Speak to that. How could the adoption of secure multi-party computation help kind of shape a new era of online privacy?
It can potentially drastically change the picture, because right now all of these systems, the way that they're designed or set up, or all the business models around data is very different than the one with secure computation. I can give you a few examples. Right now, as of today, if you want to use some online free services, why they're free? They're free in exchange for some data from you. And that's the whole debate around like privacy. Are they using our data in a proper way? Do we have visibility? There are all these kinds of privacy, very reasonable privacy concerns and questions, and they have to be addressed. And it's usually very, very hard. Like big tech companies, they're struggling with addressing these problems. Now, with secure computation, you can still satisfy some of these business models, because the eventual goal is the insights, not the individual records. So right now, today, if you think about maybe 2 or 3 step process where you have some data distributed by other people, you aggregate it in a central server. Let's say this is one of the tech companies. And then they have access to individual records. What do they do with it? They create some AI models, they extract some insights, and they benefit from that insights. Now we can think of removing this middle step. There doesn't have to be a central server where it stores raw or plain text data. We can go from encrypting data to insights, which satisfies the need of big corporations, and they can operate as they're operating before. And at the same time, we get the best of privacy.
What are some of the barriers? So now we talked about, what the potential is. What are some of the barriers to overcoming adoption for this SMPC or secure multi-party computation technology?
There are a couple. One is awareness. When we pitch this technology to some corporations, they're really skeptical. They're asking like, it's impossible. Usually the comments that we receive is either it's impossible, you guys probably did something wrong, you don't know what you're talking about. You can either keep data confidential or use it. You cannot have both at the same time. So these are some comments that we have received even from relatively speaking, sophisticated companies in the past. So that's one number. That's number one, awareness. Number two is like building these systems. It takes some time to build systems that are scalable, even especially for new technology. Like we are doing our best. We actually open sourced our platform 2 months ago with the claim that any software developer without any knowledge in cryptography can use the system and build applications that can process encrypted data. And I think we have lived up to that claim. Right now, if you look at our APIs, you don't see encryption, you don't see keys, you don't see any like a complex cryptographic operation. It's very simple programming language. We have our APIs. You can start describing what is it that you want to do with encrypted data. And then you can run it using, we call the platform Cipher Core. And then you can use Cipher Core to run it over encrypted data. So we think that open sourcing that platform would hopefully accelerate awareness and adoption by a lot. Because now, given that the technology is very interesting, we hope that more developers would start engaging with this platform, start using it, improving it, giving us suggestions, feedback. Obviously, it's not perfect, so that's one of our goals. We want to get as much feedback as possible and improve the system. And I think eventually we would get there. We are not too far from it. So that's one. Number two is computational overhead. I mentioned that our overhead is significantly lower than anything that is out there or was created in the past, but it's non-zero. You can never expect it to be zero. There is no such thing as free lunch. Like either you want to run computational over plain text data with no security guarantees, or you want security guarantees with some overhead. That's fine. But we want to minimize this overhead. And I think we have done great deal of that. Now we can run neural networks on encrypted data sub-second in few tens of milliseconds, which I think is pretty reasonable for any even real-time services, let alone like offline services, which comprise a big portion of the overall analytics landscape. So I would say these are the top two: awareness / adoption, and number two is computational overhead.
Okay, great answer. So now that we understand a little bit more about the technology we're talking about today and the current state of it, let's dive into kind of the company origin story and the people behind the company. Talk about the insight or just the origin story. What of those two things? What's the origin story, or what's the insight that led to founding CipherMode?
Yeah, so the company is founded by three people: myself, Ilya Razenstein, a brilliant computer scientist from MIT, and our third co-founder is Dr. Sadegh, who is a former CTO of NXP Semiconductor. And actually, there's a very interesting story behind it. When I was working at Microsoft Research, Ilya and I used to talk about how crazy is it that nobody is using this technology. And we were really thinking about what is the potential, like what is the end state, what is the ideal case scenario. And when you think about it, you can accomplish very, very interesting things. You can have AI-based therapists, and they can help you without storing raw information, which could arguably be the most sensitive data that you possibly want to protect in your life. But at the same time, you want to seek help. So you can do that, actually. You can allow hospitals to collaborate, especially on clinical studies where you have very limited samples per each clinic, and you want to aggregate that and come up with better insights. For anything related to genome, DNA is a very, very sensitive information. It's hard to emphasize how sensitive it is and how easy people just give it up these days to companies that are sequencing it. In an ideal world, you would have an encrypted version of your DNA, and then you would benefit from any type of analysis over your DNA to better understand your body and what diseases you're more susceptible to, but without giving up your DNA. So we were kind of like thinking about all these possible applications, and we thought that it's very hard to accomplish that in a big corporation, because we don't have the the freedom, we don't have the freedom of operation, the autonomy, and we thought that we have a different approach, and we wanted to give it a shot. So we quit our job 2 years ago, and we were really heads down thinking about all these building blocks and how we can put them together to make such system possible. And it took us 6 months. And after that, we got our first outside money from a VC in Boston called Pillar. And after that, very recently, 2 months ago, we got backed by Eric Schmidt's fund, the previous CEO of Google. The fund is called Innovation Endeavors. We also got backed by 14 great technologists, people like Jeff Dean, the head of Google AI, and 13 really, really unique technologists and entrepreneurs. And just to finish the story, at the same time, actually, even before that, I met Fari in a security conference, and he shared a very similar vision. He wanted to build a new system, a new data platform, but he thought that, again, it's a much better opportunity to do it outside in a new company with full autonomy. So that's how we got together, and then the CipherMode grew since then.
Okay, so it sounds like a strong group of people. Can you talk about next timing? Timing is so important when it comes to startups. Why is the time right now for this company and this technology?
Yeah, it's a very good question. We got that a lot during our fundraising at Seed Round. It's a good time because it's not too late and it's not too soon. It's not too soon because previously the overhead was so large that you couldn't really argue with companies to go to secure computation mode and tolerate that additional overhead. But now, still we have overhead, but it's reasonable. We can actually accomplish large scale tasks. And it's not too late because it's the very early of this technology. There are no real products out there. We are pioneer in this field. We open source the first of its kind platform. So it's very exciting for us. We are blazing a new trail. It's very exciting. So I think there's no good answer to this. I might be wrong, but I feel like the combination of not being too soon and not being too late, I think the timing is good. It's much better than a few years ago. There are more people that are aware of secure computation. We heard less and fewer times that this technology is not possible. So I guess that's a good sign.
Yeah, and you're hearing less of that now. So I did see that you released the open source library CipherCore. Is that kind of your product? Like, what's your go to market strategy here? And talk about starting an open source project and what that's like.
Yeah, it's very complicated. There are many good reasons to open source and not to open source, and we were debating this for months internally. And what we ended up with was that, on the one hand, we really needed transparency because this is a piece of software that seems like a magical black box, and people are a little bit skeptical about it, and it's touching the most sensitive data of the corporations. So we thought that transparency is a very important element, and we would accomplish that by open sourcing the platform so that people can scrutinize it, they can find bugs. It's much better way of building a security product than something closed source. On the other hand, we thought that if you open source all of our code base, then we as a business, we will face some threats, right? So basically any big corporation, other startups could copy and start using that system fully. So what we ended up with, I think, was a good compromise. So we open sourced the part that is responsible for encryption so that people can scrutinize it. The part that developers need to see, understand, and build applications on top of it. You can go on GitHub, you can clone our clone CipherCore, build your applications, test it, measure the performance, and see the computation graph, see the protocol. You can do all of that for free. The only part that is not open source and it's not completely free is something called runtime. And this is useful, this is needed when you want to really deploy this on multiple data sets, not a local evaluation. You really want to benefit from connecting multiple data sets. And that's where we have a 90-day free license, but after that, you need to purchase the license from us. So that's how we want to monetize the platform.
Got it. So the proof of concept is free, but in order to start, really using the strength of this application, which is kind of like combining data sets, that at runtime, that's when your license comes in.
Exactly. And we have a second product. We call it Secure AI. It's not out there yet, but it would come later this year. Okay. And the difference is that with Secure AI, you can use a standard AI frameworks like PyTorch and TensorFlow with their APIs without even looking at our own API, which is API stands for Application Programming Interface. That's how you talk to the systems. Mm-hmm. And we think that would accelerate adoption for data scientists. That would be the next step.
Can you talk, since we're here, talking about what's on your roadmap?
So we open source CipherCore, but it doesn't mean it's perfect, right? So we optimize for the earliest time that we can release something that has value. So we did that, but there are many missing features. There are many things that can be improved. We have a lot of ideas on improving the performance. We're not even close to an optimal point. So one direction is to constantly improve CipherCore. We have a Slack community. We always invite developers and privacy advocates, secure computation enthusiasts to contribute. That's one direction. The other direction is Secure AI, which is, think of it as a custom version, but more efficient and more easy to use version of CipherCore for AI applications. When your goal is solely AI training and inference, in contrast to other type of data analytics, SQL queries, BI, business insights, and a bunch of other tasks. So it's basically more focused, which as a result, we can get some benefits, simplicity to use it, and also efficiency. And then the third direction that we're pursuing right now is a whole suite of UI and enterprise features to help people integrate this whole system with their current systems. That's a big part of the adoption, right? So integration is a big part of adoption. And we want to minimize the friction on that front too. So these are the three major areas that you're working on. And within each, you have a lot of topics in cryptography and algorithm that we are working on. We have a lot of complex system design, obviously a lot of code to be written, a lot of verification of why this code is secure and is implementing what you intended in the first place.
Next, let's look under the hood. Talk about your technology stack and what kind of important decisions you had to make early on.
Well, many. So I guess the most recent one was open sourcing or not open sourcing CipherCore. Going back maybe on day one, whether to use secure multi-party computation or homomorphic encryption, or actually there are also other exciting privacy-enhancing technologies like differential privacy, federated learning, secure enclaves. So it's not just one technology. And there would be many, many successful companies on all these privacy-enhancing technology fronts. We think that SMPC is the one that is most suitable for long-term computation environment. It's a very clean way of doing collaboration. It's a very clean way of deploying it. For example, when you want to use secure enclaves, which is a technology that protects some part of the memory when you're doing computation. The manufacturer of chips, Intel or AMD or other companies or ARM, they say that we protect this part of the memory so that your data is not disclosed to other processes running on the same hardware or to even the operating system itself, which is a big claim. But the way that they're doing it is the security is coming from hardware isolation. It's not coming from cryptographic measures. And we think that that's a very, very important consideration. One of our design principles is that we want to have a software-only solution where you can run it on any cloud, any environment, and do not think about the underlying hardware. You are not tied, you are not glued to the hardware. It's a very lightweight encryption layer. You can put it on any sensitive data source that you have. So I guess one of the challenges was just navigating through these complexities. Like, there are many use cases where differential privacy is an excellent choice. Federated layering could be an excellent choice. Enclaves. But when you want to build a system for enterprise, hopefully for decades, you need to think about what are the fundamental principles. And we think one of the fundamental principles is that you have to be generic. You have to be able to support different kind of scenarios, different number of users, different environments. You shouldn't be tied to another company. Even us, like, we, part of the reason that we open source CipherCore was that to give confidence to other companies that we as a startup, even if you go out of business, you would always have access to this code because it's released under Apache license, which is very permissive. And that gives people the confidence that, okay, I can now invest my time and energy and my resources and my employees on building systems based on secure computation.
So we talked about earlier about, who's typically using secure computation, and it's big, it's governments, it's big organizations. But for you at CipherMode, who's your ideal customer, and how are you building awareness among them?
Right. Our ideal customer is a type of company that, first of all, they're technology savvy. They're sophisticated enough to understand and use these systems, which makes our life way easier, given that we, as a startup, we are always under the sense of urgency. So we need to go after the companies that also have some sort of urgency because of their need. And what we found out was that usually it's companies that are technology savvy, and their business model heavily depends on their data and the models that can come out of it. So basically, companies that their whole business model is around insights. And if that's true, if all three are true, then you're dealing with a company that is desperately looking for more data. What is prohibiting them from accessing more data? Privacy regulations, security concerns, mistrust, long legal contracts. And just like, it's the current computations environment is not built for collaboration when you don't have trust. Like, on the internet, the early version of the internet, the way it was set up, we didn't have secure communication. So if you wanted to do, let's say, Google search, if somebody intercepted your message, like one of the routers on the internet, they could understand what you're asking Google, which sounds a little bit crazy today, but they could have direct access to what you requested from Google, or they could read your emails. That was crazy, right? So the reason what people did was that they came up with secure communication. So now it's protected against everybody on the internet, and only you and the destination can read the message. Perfect. Now you can have that. Okay, if you can have that, you can send credit card information. And the whole e-commerce came out of that. There would be no Amazon without secure communication. There couldn't be. How can you securely exchange information over the internet without me intercepting your message, like stealing your identity or ordering other things to my address? Like, it gets so messy that you cannot accomplish anything meaningful. And now we have e-commerce established on top of secure communication. Like, we think that there could be a lot new industries built on top of secure computation with this new idea.
Do you have any success stories that you want to share, or examples of a happy customer?
Yeah, actually, my favorite one is that we were even earlier days, a few months back, earlier this year, we were talking to a Fortune 500, and the good news was that they were already familiar with secure computation, and they already investigated a couple of other vendors, and they play around with homomorphic encryption. So that was the good news. The bad news was that they were a little bit disappointed with the current state of technology and current tools and products in the market. And they said that, guys, we love secure computation, but we don't think it's really ready for deployment, and we do not really want to spend a lot of resources on this. And our response was that, say no more. We make it a free experiment for you guys. Just tell us what exactly you need. Like, what is the computation? What kind of performance do you need? What is the threshold for overhead that is acceptable to you? And they were really clear about this. They said this is our computation environment, and we need to process 20 encrypted queries per second. It was a very clear number. So we built a system for them, and we delivered 32. And when we delivered 32, they were really excited about this. They tested our system in their own environment. They made sure that our claims are correct. But at the end, that was the main force that pushed them to talk about like contracts and long-term support of CipherMode. So that was a very, if not pivotal, very interesting and important moment for us as a company.
Yeah, kind of along those lines, like pivotal moments. When you look back, you've done a lot. You've had success with customers, you've raised capital, and you've released an open source product for developers to use. In your mind, when you look back, like what are some of the milestones you're most proud of that you've achieved so far?
Yeah, that's a very hard question. I guess it's a tie between a couple of things, maybe everything you mentioned. So I guess some very exciting moments for me was when a couple of my friends and people that I really respected professionally decided to join the company, especially in early days when we had like 5 months of runway. We had like 5 months of money in the bank account, and they quit their job and they decided to join us. We have had like multiple fundraising rounds since then. We also got the money from National Science Foundation. So now we have runway for 2 years, even if you have like zero customers. So it's a very different story. But I'm really grateful that they trusted us and they joined. When some people were a little bit more skeptical, they said that, guys, some VCs treated us as recovering academics, which is very common actually in the startup world. When you have like PhD, but you're tired of academia, and you say, okay, fine, startup sounds cool, let me do it. And then after a few months, you burn out, and then you say, this is not for me, and then you wasted some capital, and then you go away. So we are like fighting all of that. Plus the fact that there were a couple of well-known cryptographers already had startups in this space, and we had to always constantly prove that we have a chance against them. So that was very interesting that at least our friends shared the same vision. They really believed in the mission of the company and they joined us. And I think tied to that is the recent capital that we raised. We raised it from Innovation Endeavors, which is a very well-known firm in Silicon Valley. And after they talked to us for a long time, they did the due diligence, they moved forward, and that was a very good validation for us. We thought that, okay, if they did so much digging and due diligence and they decided that we're best in class, that's a very good validation. We felt like really proud of ourselves.
Well, what else is out there? Have you managed to build any partnerships with other players? Are there strong partnerships to be made, or?
Yeah, we are working on a lot of partnerships. Most of them I cannot talk about because they're not finalized. But the one that have happened, the past one is we're part of MPC Alliance, which is kind of like a main consortium of secure computation companies, and with also some sponsored by big companies like Meta and a bunch of others, that with the mission to standardize and add promote secure multi-party computation. And obviously every secure computation company would benefit from that, so that's why we are part of this community. We are also part of Data Collaboration Alliance, which has a similar mission, but it's not about secure computation. It's about the idea of like data sharing, data collaboration. It's about creating data marketplaces. It's about how we can put one and one together and achieve three. It's about that. It's about the value of like larger scale data. And also we are working with National Science Foundation to advance the technology because they think that this is of national interest, regardless of whether we make it as a good business or not. The technology itself is needed for the country. And we are also part of a couple of technology hubs, like Plug and Play is one of them. And we try to be active and really be loud so that more people would be aware of secret computation.
Big picture, what are some of the challenges you face as a founder? What are some of the challenges that keep you up at night as a first-time founder?
I guess like many, I used to sleep like a baby. Now I'm not. So I think that's all you need to know. There are many challenges. Like when you are first-time founder, it's a weird feeling. You always have this dilemma of trusting your own judgment or asking for more advice. So you have to be decisive, but you have to also take a lot of information from outside, from advisors, from other people. And because the nature of the work is noisy, because there's high entropy environment, there is no single good decision. It's not about if a successful serial entrepreneur would be in my shoes, he or she would make the right decision. It's just complex by nature. Like nobody knows the answer. Like everybody wants to build a unicorn, right? That's obvious, but it's hard because it's complex and noisy at the same time. So you always need to figure out when is the right time to make a decision in the absence of full information. That's what makes it really hard. Like when you are coming from college, when you're working on masters and when you're working on PhD, it's complex, but at least you can progress. You can break the task down into different pieces. You can almost solve different pieces. You can collaborate with other people. You're not under so much time pressure per se. It's more about like quality of the work than just being fast. But in a startup, we have a lot of like cash burn, so we have to be fast too. And as a result of that, we have to make decisions quickly. And as a result of that, obviously some of these decisions may turn out to be incorrect, and you need to just course correct and move on to the next step. So I think just being a little bit like tolerating stress and noise and so much different opinion, I think that's maybe the most challenging part.
Do you have any last minute predictions for the future of secure data sharing?
Yes, I don't think it's surprising or too shocking, but I think eventually data would be seen as something unique with one copy. Like similar to how we have devices that they have like IP addresses and they're unique and you can talk to them, data would be that. So it wouldn't be about like just creating more copies and copies of data. It's about there's a data, it has owner, and you can rent it out, you can use it, but you keep the ownership of that data, even in digital world, which is actually tightly coupled with the idea of like blockchain and the future of distributed systems, distributed ledgers. So yeah, I mean, data would have IP, and you can keep the ownership, and you can use it more freely. So I think that's going to be very, very interesting. And if you can do that, then you would have businesses that are not present today. Like before the internet, tried to explain the value of like search engine. How can you monetize it? How can you build multiple $100 billion company around that? Like it's just too hard to imagine. But I think we would see new ideas, brand new ideas, and brand new business models.
Yeah, I guess we will have to wait and see. Before we go, Sadegh, what's the best way for our listeners to reach you and CipherMode?
They can email me at sadegh@ciphermode.com. And please visit our website and check it out. It should be pretty cool.
Yeah, if you're talking about raising awareness, is that the best place to learn more about CipherMode? Is there any like recent article or anything that they should check out?
Yeah, we plan to publish blog posts frequently. If you visit our website, CipherMode.com, then you can have access to our open source platform, see a couple of examples. It's really simple. Like if you're a software developer, you can start building something literally like in few hours. You can train AI models over encrypted data for you.
Okay. All right. Well, that's where you can learn more about CipherMode. Sadegh, thank you very much. We're going to end the show there. If you liked our show, please subscribe wherever you get your podcasts and leave us a rating. Sadegh, thank you for joining the show today. We really appreciate your time.
Thank you so much.